And
Imagine if she was mute either.
It's like last week, see before you know.
okay, that's not what I wanted to share. I wanted to share this. There we go. While we're doing that, on your whiteboard, someone is looking.
On your whiteboard?
On your whiteboard, yeah.
Yeah, no.
How else are you gonna do it?
In our heads, I don't know.
Oh, no, I can't see your head. In your head. Are you in that one? It's yours. That's that. Right, but I'm going to do the y 2 minus y1 because dividing by the x. Like you slowly grind over them. So it'd be this minus this over this minus this. Now do that here. Yeah, so yeah, so x value is 2. And the grades weren't bad at all. But I know how some of y'all are. And if anybody wants to do a later test, you can. Any questions on any of the parts? I tried to, if you missed anything, I tried to see what it was you were doing. And tried to show you what you should have done. It may not have been real clear though. So you can check on the test if you did this right on the test. What do you have? L is the limit as x approaches c of f of x. If and only if for any number, what? Do we have that? L is the limit. Any number epsilon, no matter how small, there is a number delta, such that, so you didn't have epsilon and deltas on this. If epsilon is within, no, if f of x, I forget which one is first myself. How about, y'all have that hand that I gave you? Can you see it there? Did I do it right? I haven't really memorized it myself, right? Let me see. Epsilon greater than 0, you're supposed to say. No matter how small, there is a number delta greater than 0, such that if x is within delta units of c, but x not equal to c, then f of x is within epsilon units. Or you can do it that way. Okay. That's just kind of, I'm going to probably throw this up here some other days too to see how much more you can get. And then I might start making more blanks. okay? So similar to the verbal one you had that we used epsilon and delta. Also, one of the things, wanted to show you how to do 14. If you look at number 12, you should have had negative 2t squared plus 20t minus 42 all over t minus 3. And if you just plug that in, you could get your graph. That's what most of y'all did. And you saw a removable discontinuity at 3. And so you had a line going down, and at 3, you should have an open circle, which says that there's no value right at 3. Okay, most of y'all did that pretty good. By appropriate algebra, simplify this rational expression. Okay, so you can divide this by this using synthetic division, or you could factor this. Some of y'all were trying to factor. And if you were going to factor this, what would be the first thing you should do? If you're setting that equal to, say, 0 or something. Now, do you see a 2 in all of them? You factor out a negative 2. You have t squared minus 10t plus 21. And then you can factor that out. However, I think the easiest thing to do on these kind of problems is to just use you want to get rid of this, so just use synthetic division. And so you put a 3 there, negative 2, 20, negative 42. Y'all remember synthetic division? I don't know what y'all had last year with COVID. Okay, if you bring down the negative 2, that's negative 6. So you get a 14 there, and you get a 42 there, and you get 0. So you end up with, instead of all this, it's equal to negative 2x plus 14. Okay. And then the limit, now you can plug in a value of 3 here without getting 0 in the denominator, because you don't have a denominator. So if I plug 3 in, you get negative, oh, let's just get 2. Negative 6 plus 8 plus 14, I'm getting ahead of myself, and you get that 8 that you found earlier on number 11. Make sense? Okay. Other than that, it was pretty good. I know the units on that BTU thing was really weird. I don't think I took off any points on number 7. Anybody? Any other questions? Okay. Well, then let's look on page 32 again real quick. Page 32, the gray page, and it has that graph on it. And so you see where L is on the y-axis and epsilon. See how they've drawn the epsilon? Then you have C on the bottom on the x-axis with a delta, delta being the distance between the solid line and the dotted line. Okay, and so, and if you look in the where it says algebraically in teal or whatever that color is, they show that x minus c is that distance, and it's between 0 and delta, and the other distance is less than epsilon. In other words, you're looking at a limit as that delta gets closer and closer to 0. Hopefully that'll make more sense. When you look at that picture, it'll make more sense as we go along. Okay. Now flip over to page 34. limit there, and they have an example, and the example shows a graph over on page 35. Look at that graph on page 35. You see a removable discontinuity? Actually, what that is called is not a removable discontinuity, it's called a step discontinuity, because the graph jumps down to another point. Okay, they call that a step. And so you see the points 1, 2, and 3 on the x-axis, and they want to know, is there a limit when x equals 1? And if you look at what x equals 1, what is the y value? That was a trick question. Because see the open circle? Because of the open circle, there is no y value for when x is 1. But the limit is 2. Its purpose, or it wants to be, what the graph is approaching from either side is 2. So the limit there is 2, but there is no function value. Make sense? Then it says that x equals 2. Now x equals 2 is continuous there, and the function value is what? Can you tell? The function value in x is 2. What's y? You're looking at the graph at the top of the page. Yeah. What? 5. Yeah, thank you. Okay. And so what's the limit at 2? The limit is also 5, even though it'd be like a closed-in circle. Instead of an open circle, it's just continuous, but that's still 5 is what it's approaching from either side. It actually gets there too. So the limit and the function value are the same there. And then when you get to x equals 3, so as say if you were writing this function from the left, you're down at the low point and you're going up, 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 what y value do you get to when x is 3? Where the closed-in circle is. What's that y value? 10. That's called the limit from the left. The left limit is 10. What about if you started on the right and you're sliding down toward 3? What is the limit if you come that way, where the open circle is? 8. And so there, 8 is the right limit, 10 is the left limit. If the two limits aren't equal, then you say at that number 3, there is no limit. There is no limit. It's kind of like you're saying it's trying to be more than one thing, and that just doesn't work. So you just say no limit. Make sense? Okay, there is a right limit and there's a left limit, but they don't meet, and so there's no limit. Okay, because they mention on C in the solution thing right next to it, it says there is no one number you can keep f of x close to just by keeping x close to 3 but not equal to 3. If you're keeping x close to 3 on the right side, you'll be getting close to 8. But if you're keeping x close to 3 on the left side, you'll be getting close to 10. So there's no one number, so there's no limit. Now the discontinuity at 1, when x is 1, that is a removable discontinuity. And then the other one's the step discontinuity. Okay. Example 2 shows the graph of a function f for which f of 2 is undefined. So do a little open circle, right? What number does the limit as x approach 2 of f of x equal? So what would you think for A? What's the limit when x is equal to 2? 4. Yeah. Okay. And so they say write the definition of this limit using proper limit terminology. And so what you could say is you'd say 4 is a limit as x approaches 2 if and only if, and so on like that. Okay, you'd be plugging those numbers in. Now they say if epsilon is 0.6, estimate to 1 decimal place the largest possible value of delta you can use to keep f of x within epsilon units of the limit by keeping x within delta units of 2 but not equal to 2. Okay, and so look at the bottom graph, the bottom of the page on page 35. They're doing that approximate thing that we did on the exploration. If epsilon is negative, it's 0.6. And so they went above 4 and below 4, about 0.6, and did the dotted lines. You see the dotted lines? And they took the dotted line over to the function and then drew an arrow down. And then did the same thing to the other one. And you've got two values. Which of those arrows is closer to 2? The one below 4 or above 4? Can you see what I'm talking about? Above or below? Below, right? The dotted line below 4, when you draw a line down to the x-axis, it's closer to 2 than the other one is. Okay, now why do you think that is, looking at the shape of the graph? Because you're the same distance from 4 above and below, but you're not the same distance from 2. So what is it about the graph that makes it unequal like that? Anybody want to answer again? Do you think it, like, what if you had a straight line like this? And you have a point. Okay, and so let's say I go down here and here, equal things there, and then go across here. I should get equal things here and here, right? If these are equal, then these are equal when the line is straight. But it's not straight, and so which side is has a smaller delta? Think about slopes. You look on either side of that open circle, and the slope is steeper. Wherever the slope is steeper, you're going to have a smaller delta. Does that make sense? You can see the picture there. The slope is steeper, so you have a, like if this was like, yeah, going straight, and then went, yeah, like that. Well, then this would go all the way over here, and then you'd have a shorter delta. So it's always the side on which the slope is steeper. Okay. And they kind of made some approximations. And then C, they said what name is given to the missing point. It's called a removable discontinuity. And now turn to page 36. We're going to get a little more computational. Example 3, figure 2.2d shows the graph of f of x equals the cubed root of x minus 3 plus 2. And the limit of f of x as x approaches 3 is 2, the same as the value, same as the function value. Okay, so let's write that equation down. X equals x minus 3 to the 1/3, same as that means the cubed root, and then plus 2. This is similar to, I think, the exploration we did. Let's find graphically the largest value of delta for which f of x is within epsilon equals 0.8 units of 2. So you can look at this in solution. They have a little graph, and they went up 0.8 and went down 0.8, and they, with their rulers, drew their little dotted lines and came up with about 1.2 on one side. 48. Oh, they did it with intersection value. Okay, so this is an interesting way to do it. Okay, so they put in this function in a calculator, and then you have 2 is kind of right here, and then down here is 3. And so if epsilon is 0.8, then you go up here to 2.8, right? And if you subtract, you have 1, you have 1.2. That would go over. Make sense? Okay. And what you can do is if you put this in for y1, and then you put 2.8 in for y2, and y3, you can put 1.2. The calculator will graph this line here and will graph this line here, and then you can do your intersection feature, second calc intersect, and find out really close where those values are, rather than just estimating it off your drawing. Okay. And they say by symmetry, the delta value is the same on either side. The way I drew it, it doesn't look the same on either side. But I think if I'd had my main spot here, it probably would have been a little bit better. And look at the math they did there. Or rather, don't look at it. Let's, on B, it says find the value of delta in part A algebraically. Okay, so here's what I wanted to do again for y'all. This is like having y equals x minus 3 plus 2. Okay, and what you want to do when you want to find what delta is you replace y with y plus epsilon and x with x plus delta. And looking at the graph, if you added epsilon, then the delta is gonna be to the right of x. So that's why I put plus in both cases. Sometimes you'll have a minus there depending on which one's gonna be closer to your, which delta is gonna be smaller. And then at this point, we can, if epsilon is 0.8, we can plug that in. Y is, your value is 3, 2. So you're gonna plug all these values in to this equation. Okay, the point and what epsilon is, and then all you have left is delta. Okay, so I would say 2 plus 0.8 equal, and x is 3 plus delta. Okay, and then this can be simplified, 3 minus 3. Okay, so this is 2.8 equals delta to the 1/3 plus 2. Then I'll subtract 2, and I'll have 0.8 equals delta to the 1/3, and then take the cubed root. The cubed root of 8 is 2. Is the cubed root of 0.8 0.2? I think they just leave it as, no, it's 0.512. That's fine. Oh, you cube it, I'm sorry. You get rid of the 1/3, you cube it. So 0.8 cubed is delta, and they say it's 0.512. I'll take their word for it. That make sense? Okay, example 4 is very similar, but you get into log and this. Let's show the algebra on that, if you remember. They have, we'll start in the middle of their problem. They're doing the same exact thing. They have 3 plus delta up here because they started with a different graph, a different equation. Epsilon. And they're leaving epsilon in there, so just any kind of epsilon. How am I going to solve for delta if I have it up there? So what would be the first thing you'd want to get rid of? 0.2, right? Yeah, so we're going to divide that. And you can just leave it like that. They actually separate this. Let me show you. And it's just like saying divided by 2/10 doesn't be the same as multiplying by 10/2. And so that'd be 16/2 would be 8. And then instead of dividing by 2/10, multiplying by 10/2, that's the same thing as 5. And then you get 5 epsilon. Okay, so those equal that. Okay, now do you remember what to do next? You get something out, a variable out of a numerator, I mean, out of an exponent. You have to use log. Remember doing logs? I think you did on Khan Academy, possibly. I don't know. That was a weird spring, right? And so what you can do is you, there's two different ways you can do it. They take the log of both sides. They take common log of both sides. Yeah, for that. Okay, so if we take the log of both sides, then what you're doing is, if this is common law, like a base 10, actually, go ahead and take the, don't need to do that. There was a rule that said, did I give y'all a formula sheet yet? Okay, but it's not on this formula sheet. So you might want to add to it the fact that I have another formula sheet that has the log thing, but you can add this to this formula sheet. I have log x to the r. That's going to equal to r log x. In other words, this exponent up here can be placed down in front. Okay, log x to the r is equal to r log x. And just while you're writing those down, write this down too. If you have log of a times b, that's the same as log of a plus log of b. And if you have log of a over b, that's the same as log of a minus log of b. These are properties of logarithms. There was one more. Okay, so what they did here, they said, well, here's an exponent. So I'm going to move it over in front. 3 plus delta log 2 equals log of 3 plus 5e. That's on. Oh, okay. So then we're going to divide both sides by log base 2. Can't cancel the logs. This is like we can't cancel square root signs. They have a function, not a variable. So that goes out. I have 3 plus delta equals log of 8 plus 5 epsilon over log of 2. And then I can subtract 3 from both sides. And I would have delta equals all of that. Okay, so they're going to expect you to be really good at all this algebra stuff. And okay, here's what we're going to be starting on. Next, I want you to go to the board and work the first few. We're going to do, and you can put DOB for some of these, section 2.2. You do the Q's. This is page 37. 1 through 12 all. And then we're going to do also 13 through 27 odd. And we will be working tomorrow also. So is epsilon, is that associated with X or Y? Y. And delta is always associated with X. That's good to remember. Okay, so I'm going to erase. I'm going to have y'all go up to the board to do the Q's and this 1 through 12 all. I'll tell you. Okay, so Q1, sketch the graph of y equals 2 to the x. You might want to have your book, if you don't remember how y equals 2 to x is, they showed you parent functions back on page, where was that? Oh, it told you the types. It didn't show you the actual functions. On page 6, they talked about the types of functions. They didn't actually graph them. So if you remember an exponential function like that, where the variable is in the exponent, draw your xy axis, and actually just look what Maddie's doing. It's going through 0, 1. These are those kind of functions that go through 0, 1, and the asymptote along the x-axis to the left. And it gets really high. And Brian, you just plotted a few points, huh? You figured it out. Good job. Did you know what 2 to the 0 is, and 2 to the 1, and 2 to the 2? But try to keep in mind that when I say exponential, that's what we're looking at. Okay. I haven't drawn it yet. Kate, did you draw it? Oh, yeah. Or you can use your calculator, what calculator's in, and then look at it, and then sketch from there. So what about y equals cosine x? That's Q2. Y equals cosine of x. Oh, did your graph? Yeah, sure, sure. It also comes out to sometimes. You have the x back. That's just having taught me. So the cosine. So Maddie, you look like you're thinking of the sine. The sine starts at the origin like that. Cosine starts up at 0, 1, and then, I mean, it doesn't start there, but it goes through 0, 1 like that, yeah. And you can go the same way on the other side of the reflection of it. Yeah, Kate did a good job. And formula sheets do have the trig functions drawn on them. I like the domain that Brian put on his. Okay. Now Q3 says sketch the graph of y equals negative 0.5x plus 3. Could you change negative 0.5 to a fraction so you would know the slope? Negative 1/2 x plus 3. You start up at the y-intercept, 3, and then down 1/2, down 1/2. Like it goes through that, where, 6. You can also, in your head, plug 0 in for either x or y and find the x-intercept. You can plug 0 in for y, and that will tell you the x-intercept, and then it's easy to graph. Okay, the next one is sketch the graph of y equals negative x squared. Y equals negative x squared. You know, x squared is a parabola. But the negative means you're going to flip it over the x-axis. So it's a sad parabola hanging down. Okay, good job. Okay, now you could use some creativity on this one. It says sketch the graph of a function with a removable discontinuity at the point 2, 3. So you can draw the graph however you want to, as long as it has a discontinuity at 2, 3. And At that point, there should be a little open circle. Ah, nice variety. Everybody has a decreasing slope. Wow. Like cakes, you guys are kind of almost a corner there. That works. Okay, now Q6. Name a numerical method for estimating the value of a definite interval. A method for estimating a definite interval. There's actually more than one answer for this. A numerical method for estimating the value of a definite interval. Here. I'm thinking counting the squares would work. But I bet they're looking at it being the trapezoidal rule. They're using actual function, like data from the chart. So I forget more what they're talking about. Trapezoidal or trap rule. Okay, what graphical method? Yeah, this is the counting squares one. What graphical method can you use to estimate the value of a definite interval? The graphical way is counting the squares. The numerical way is trap rule. Does that make sense? Okay, Q8. Write the graphical meaning of derivative. Graphical meaning of derivative. And 9 is the physical meaning of derivative. Do you remember either one of them? I'll tell you which one it is. What's one of them? So tangent line, that's the graphical, yes. Graphical meaning of the derivative. The physical meaning. Okay, got it. Yeah. Instantaneous rate of what? Rate of, okay, so you need to flip here. So the instantaneous rate of change is your physical.
I just wrote the other one.
Okay, and so the tangent line is the graphical. Okay, number 10 is a multiple choice. So if log base 3 of x, write that down, log base 3 of x equals y, then you have choices. Like if you convert that to exponential form, you know how to convert that to exponential form? But you get 3 to the x equals y, or y to the 3 equals x, or 3 to the y equals x, or x to the y equals 3, or x to the 3 equals y. What did you get? And that's something else you can put on your, it was, I think it was A, wait, no, it was B. It's not C, it's B. Something you can write on your formula sheet is you have some base to the exponent that equals some number, then you do the same thing as log base b of the number of x. So these are interchangeable. We started with this. So yeah, you do need to know how to go from exponential to logarithmic. Okay, so that's all the cues. Now, number 1, let's write the definition of a limit without looking at the text.
I already did
How about if I give you some blanks? Okay, blank is the limit. What is that? L, good. L is the limit of what? Of f of x as what happens? As x equals c, if and only if, I have that. For any number, what? Epsilon greater than, let me just bring it in. 0. Epsilon greater than 0. That means epsilon has to be a positive number. Not less than 0, less than greater than 0.
It's what I thought in my head. I know.
No matter how small, do you want to get epsilon t? There is a number. What? delta greater than 0. Yeah. Here's the number delta greater than 0, such that if what? If x is within how many units? If x is within blank units of blank, delta units of c, right? But blank x not equal to c, then, last line, then, not x, but f of x is within the other kind of unit. And f of x is within, you already used delta, so it's epsilon units of L. You gotta keep working on that. Like when you brush your teeth in the morning, just have it there so you can say it. It always sounds cool. One year, my students actually made hand motions. Something remember.
No, I mean like,
What were they?
If you know what they were.
I think, or they did that. L. And then they had a C. And they had epsilon.
The king's sound now.
I know, epsilon, and then greater than 0. And just, I can't remember exactly. It was pretty cute.
Wait, what class was that? Last
I
year?
don't think it might have been, no. Here we had, they had Brian, whatever his last name was. And Becca, which is Jesse's
Yeah,
sister.
that was the-
That group was old people. Okay. So you got the, okay, so number 2. What is the reason for the restriction, but x not equal to c in the definition of a limit? Why do we have that in there? Why is it needed?
It's what she said.
Actually, it's more of a graphical thing than a mathematical thing. Because, but why cannot x? Because there might be a removable discontinuity. In other words, there might not be a unit at C or a function value at C. The book says because the value f of C may be undefined or different from the limit.
But it's also because you can't have a 0.
That was number 2. Okay. So number 3, you're gonna need your book because it's a visual thing. That's for problems 3 through 12, state whether the function has a limit as x approaches C, and if so, tell what the limit is equal to. Yeah, so number 3, it is what? What is L? And 4, what is L? Start off with UD. Then you got all the way down to 12. And if there is no limit, say D in, does not exist, D and E. Right, D and E does not exist. Six, it does exist. And 5, it also does exist. What number is the graph pretending to get to, but maybe not get to, but it pretends it's going to? I know, they have that little point floating up there. That's okay. 9 does exist, and so does 10. And y'all like that D&E, right? Four of them don't exist. You check them?
No.
I will check. Catherine. One of them's wrong. That's some of them wrong. No, you just don't know which one.
I was thinking of
So everybody had 3 for 3. 3 is good. 3 is 3 for 3. Okay, 4 is 2. 5 is 3. And 6 is 5. 7 does not exist. 8 does not exist. 9 is 7. 10 is 20. 11 does not exist. Or infinity. And 12 does not exist. Any questions on any of those? Okay, on 13 through 18, you have to have a photocopy, which I think I had a copy of it. I'll run with you that. And so you're done with the board. See if I made that copy or not.
First time I think. Pretty sure.
I did.
Yeah, 39.
That's the odds and the evens. We don't just do the odds. Okay, so hopefully you can do all these. You can say DOB and that's and I am going to end the meeting.